Hi there, in this video I'm going to do a past exam question on differentiation. So let's take a look at this question. The curve C has equation y is equal to 4x plus 3x to the power of 3 over 2 minus 2x squared, where x is greater than 0. And in part A, we need to find an expression for dy over dx. So let's go back to the paper and pen. So here it is, the equation y equals 4x plus 3x to the power 3 over 2 minus 2x squared. Now, if you're unaware in terms of how to find dy over dx, I have created a video explaining the process, and I'll provide a link to this video in the description below. However, for this particular example, all we need to do is we need to multiply by the power and subtract 1 from the power. So that is the process for working out dy over dx. So here goes. dy over dx is, when I differentiate 4x, I'm going to have 4. When I differentiate 3x to the power 3 over 2, we're going to have 9 over 2 x to the power 3 over 2 minus 1 is half. So if you multiply by the power, 3 over 2 times 3 is 9 over 2. And if you subtract 1 from the power, 3 over 2 minus 1 is half. And when you differentiate minus 2x squared, multiplying by the power, 2 times minus 2 is minus 4. Subtracting 1 from the power, 2 minus 1 is 1. So you should have minus 4x for the derivative of that term. So this is what you should have for dy over dx. So this is a solution to part A. Let's go back to the screenshot. So we have a part B. Part B is to show that the point P has coordinates 4, 8, lies on C. So let's think about this problem. So let's get back to the paper and pen. So here is P with coordinates 4, 8. Now, in order to show whether this point lies on our curve, let's simply put the x value in, and let's double check whether we get 8 as the corresponding y value. So the equation given in the question is 4x plus 3x to the power 3 over 2 minus 2x squared. So let's put the x value, which is 4, into this equation, giving us y, which is 4 into x replaced by 4, plus 3 into x replaced by 4, to the power 3 over 2 minus the 2 x replaced by 4 squared. Now if we work this out, we do indeed get a y value of 8, which corresponds to the y coordinate of 8. So this means that this point 4, 8, which is the coordinate of P, does indeed lie on the curve. So let me just close by saying therefore P, which has coordinates 4, 8, lies on the curve C. So that should be the solution to part B. So we have more parts to do, so back to the question. So in part C, show that an equation of the normal to C at the point P is 3y is equal to x plus 20. Now, if you're not sure of how to calculate the equation of the normal, I have created a video explaining the process, and I'll provide a link to that video in the description below. But let's briefly talk through it. So for the equation of the normal, I need the gradient of the tangent. And for the gradient of the tangent, we need the gradient function dy over dx. If we go back to the paper and pen, we have dy over dx from part A. So dy over dx is 4 plus 9 over 2 x to the half minus 4x. So to work out the gradient of the tangent, we need to put the x value of P, which is 4, into dy over dx. So let's work out the gradient of the tangent at P. I usually name the gradient of the tangent M1. So M1, the tangent gradient. If I put the x coordinate of P, which is 4, into dy over dx, this is what we're going to have. We're going to have 4 plus 9 over 2, x replaced by 4 to the power of half minus the 4, x replaced by 4. So this is what we should have as a result of putting the x coordinate 4 into dy over dx. And when we calculate that, we'll have 4 plus 4 to the power half is 2. The 2 and this 2 will cancel to leave us with 9. Minus 4 into 4 is 16. And if we go one stage to simplify, we should have an answer of minus 3. So minus 3 meaning the gradient of the tangent at P. Now, what is a normal? Now, a normal is a line which is perpendicular to the tangent. We need to use this condition for two lines being perpendicular. So for two lines to be perpendicular, the product of their gradients equates to minus 1. So let's use that condition to work out the gradient of the normal. The normal gradient, I normally write that as m2. m2 the normal gradient, so we're using the fact that m1 times m2 is minus 1. So the product of the gradients equate to minus 1 for perpendicular lines. And since the normal is a line perpendicular to the tangent line, if I rearrange this, m2 is minus 1 over m1. Now the value of m1, the tangent gradient, we have minus 3. So it's going to be minus 1 divided by minus 3. Minus 1 over minus 3 is 1 over 3. So 1 over 3 meaning the gradient of the normal. So we've got the gradient of the normal. So going back to the screenshot, we need the equation of the normal. So since the normal is a straight line, let's use the equation of the line formula. Since the normal passes through the point 4, 8, so the normal and tangent generally pass through the same points, and we have the gradient of the normal. So back to the paper and pen, the gradient is 1 over 3, the normal passes through the same point as the tangent, so 4 and 8. So let's use the equation of the line formula. So the equation of the normal at the point P, so the line formula is y minus y1 is m into x minus x1. Now in this formula, x1 and y1 are the coordinates of the points where the line passes through, and our normal passes through P. P has coordinates 4 and 8. So let's make a note, 4 and 8 for x1, y1. M is the gradient of the normal m2. And let's remind ourselves, m2, 1 over 3. So let's make a note, m2, 1 over 3. So we have everything that's required. Let's put that into our formula. So y minus y1, which is 8, that is equal to m, which is 1 over 3, x minus and x1, which is 4. Let's get rid of the brackets. So we have y minus 8, that is a third x, so a third times x is a third x, minus third times 4, or third times minus 4 rather, is minus 4 over 3. And if I take the minus 8 to the right, y will then be a third x minus 4 over 3 plus 8 is plus 20 over 3. So that will be the equation of the normal. So let's go back to the question. So we need the equation of the normal, and we need to show that this equation can be written in this form, 3y equals x plus 20. So back to the paper and pen. So we're almost there. If I multiply every term in an equation by 3, multiplying by 3 will give us 3 times y, which is 3y. That is equal to a third times 3 is x, plus 20 over 3 times 3 is 20, and that is the form that is required. So that completes part C. Now, back to the screenshot, so we have another part to do. Part D. Now, the normal to C at P cuts the x-axis at the point Q. And in part D, find the length PQ, giving our answer as a simplified surd. Now remember, bear this in mind, when a curve cuts the x-axis, the y-coordinate is 0. So when our normal cuts the x-axis, the y-coordinate is 0, meaning that the y-coordinate of the point Q is 0. So we can put y equals 0 into the normal equation to work out the corresponding x-coordinate. So firstly, let's work out the coordinates of Q. So when the normal cuts the x-axis, y is 0. So if we put y equals 0 into this normal equation, we'll get 3 into 0 for y. That is equal to x plus 20. Now, if we rearrange this, we're going to get that the x value is minus 20. So minus 20 should be the x-coordinate, and it's the x-coordinate of Q. So Q will have coordinates, x being minus 20, the y-coordinate 0. So if we go back to the screenshot, so referring to the question, we need to find the length of PQ, giving our answer as a simplified surd. So going back to the paper and pen, we have the coordinates of Q, minus 20 and 0, and P has coordinates 4 and 8. So 4 and 8 are the coordinates of P. So we have the P and Q coordinates. So let's find the length of PQ. So P has coordinates 4 and 8. I'm going to call that x1 and y1. Q on the other hand, minus 20 and 0. Let's refer that as an x2, y2. And remember, to work out the length, in this case PQ, there is a formula, and the formula goes like this. It's the square root of x1 minus x2 squared plus y1 minus y2 squared. So if you're unaware in terms of how to calculate the length, I have created a video explaining the process, and I'll provide a link to that video in the description below. So let's move on. So we have square root of, now x1 is 4, so 4 minus, x2 corresponds to minus 20, squared, plus y1 is 8, minus, and y2 corresponds to 0, squared. So let's continue. So in this case we have 4 minus 20 squared. 4 minus 20 is 24. 24 squared is 576, plus 8 minus 0 is 8, squared is 64. And 576 plus 64, and if you simplify that root, you should have 8 root 10. So you're going to have 8 root 10 as a simplified surd. So that should be the solution to part D. So that completes the question, and that's also sadly ends this video. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like is very much appreciated. Do plenty of practice problems, and I hope to see you again. Thank you.